Solving quadratic equations by completing the square. We've been working with quadratic equations all semester. It has an equal sign, that's what makes it an equation. If a variable has an exponent of 2, it's a quadratic equation, and the method we've been solving is by factoring. So we still need to be able to recognize a quadratic equation, like example 1, equal sign. We see that exponent of 2 quadratic equation. The way we solve by factoring is to put it in standard form, getting all the terms on one side of the equation. In other words, setting it equal to 0, and factor. This particular equation factors into x plus 2, x plus 5. Set each factor equal to 0 and solve. Gives us two solutions, -2 and -5. Example 2 is a smaller equation, but it's still quadratic. In order to solve by factoring, we still need to set it equal to 0, putting it in standard form. Difference of squares factors into x plus 5 times x minus 5. Set each factor equal to 0 and solve. It gives us two solutions once again, -5 and +5. Example 3. Equation. X inside the set of parentheses has an exponent of 1, but of course that exponent of 2 is going to apply to everything inside the set of parentheses, so it is a quadratic equation. So in order to try and solve this one by factoring, we still need to set it equal to 0, putting in standard form, so we are going to have to end up foiling the left-hand side. It's going to FOIL into x squared minus 18x plus 81 is equal to 54. Subtract 54 from both sides. X squared minus 18x plus 27 is equal to 0. Then we try and factor the left-hand side. However, in this case, we see it cannot be factored. So the factoring method does not always work, which means we're going to have to introduce some other methods for solving quadratic equations. We're going to introduce a few more methods for solving quadratic equations. The next method is called extracting the roots. It does not always work either, but when it does work, it's a pretty easy method to solve quadratics using extracting the roots. What you have to do is figure out, first of all, when this method will work. Extracting the roots works when all the variables in the equation are being squared. So if you go back up to the first three examples, example 1, we saw by factoring, but this new method, extracting the roots, only works if all the variables are being squared, which does not apply here because we have that first x that is not being squared, so extracting the roots would not work to solve this equation. Example 2, x squared is equal to 25. Here we only have one variable that is being squared, so this new method, extracting the roots, would work as well. So we're going to solve this equation again using this new method. In order to solve by extracting the roots, we want to begin by getting the power by itself on one side of the equation, which it is in this case. Then we want to get rid of it. The opposite of squaring something is to take the square root, and of course whatever you do to one side of the equation, you have to do to both sides. But when you take the square root of both sides of an equation, it's not just going to be the square root of 25, it's going to be positive and negative the square root of 25. So then when we simplify the left-hand side, of course that square and square root cancel each other out, leaving us x is equal to plus or minus the square root of 25. Simplify that radical, of course, is just 5, so plus or minus 5. So that's two solutions, which that notation is fine, or you could separate them and write them individually as x is equal to 5 and -5. Obviously the same two answers as we came up by factoring, but you can see it's still a pretty easy, quick method to use. Example 3, this equation we could not solve by factoring. But what we notice is that all the variables are being squared. There's only one x, it's inside the set of parentheses that's being squared. So this extracting the roots method should work. Begin by getting the power by itself. It is. So get rid of it. Take the square root of both sides, not forgetting that plus or minus. The left-hand side, square and square root cancel out, leaving us radicand x minus 9 is equal to the right-hand side. Simplify that radical. Square root of 54 becomes plus or minus 3 times the square root of 6. We still haven't solved the equation yet. Get x by itself. Add 9 to both sides. 9, or x is equal to 9 plus or minus 3 times the square root of 6, which once again, this is technically correct the way it's written here, as long as you understand that it is two answers. And a lot of times my math lab will want you to separate these two answers just to make sure you understand that once again is two solutions to that equation. Example 4, quadratic equation. Now that we have two methods for solving quadratics, you always want to begin checking to see if this new method will work, extracting the roots. Check to see if extracting the roots will work first. If it does, go ahead and use it. So in this case, we only have one x, one variable. It is being squared, so it will work. We do have a little bit of work to do in order to get that powered by itself. Subtract 11 from both sides. Divide both sides by 3, so x plus 1 squared is equal to 24. And now that that power is isolated, get it by itself, take the square root of both sides, not forgetting your plus or minus. The left-hand side leaves us just the radicand, x plus 1 is equal to, the right-hand side simplifies to plus or minus 2 times the square root of 6. And finally, solve for x, subtract 1 from both sides, negative 1 plus or minus 2 times the square root of 6. So if you separate those two answers, negative 1 plus 2 times the square root of 6, negative 1 minus 2 times the square root of 6. And example 5. In this case, extracting the roots will not work. Not all the variables are being squared. So then we go on to factoring. See if we can solve by factoring, put it into standard form, setting it equal to 0. And in this case, we see factoring will not work either. So now that we have two methods for solving quadratics, we see we're still going to have to introduce another method. This method is called completing the square, the third method. This method always works. It'll solve any quadratic equation. But we don't always want to use it because it's a pretty long, drawn-out method. We just want to use it when we have to. So you can go through the steps reading how to complete the square. First step, we will of course want in standard form the quadratic, but we need to make sure a is equal to 1. The leading coefficient must be equal to 1. If it's not equal to 1, we need to make it equal to 1 by dividing the entire equation by a. Then what we're going to do is move c, the constant, over to the right hand side of the equation, and then add 1/2 b squared to both sides of the equation. The left hand side will then factor into a binomial squared and simplify the right hand side. At this point, at this step in the process, what we have done is taking a quadratic equation that could not be solved by extracting the roots and converted it into a form where now it can be solved by extracting the roots. So basically we continue solving the equation by extracting the roots. Take the square root of each side and simplify. So let's look at example 1 here. This one, quadratic equation in standard form, could not be solved by extracting the roots. Not all the variables are being squared. But it can be solved by factoring. So we'll go ahead and solve it first of all by factoring. It's going to factor into x plus 3, x plus 9. Set each factor equal to 0, gives us two solutions, negative 3 and negative 9. But just for practice and to show you that it always works, we're going to solve by completing the square. So going back to the original equation, quadratic equation in standard form where a is equal to 1, b is equal to 12, c is equal to 27. So take a quick check, make sure a is equal to 1. We just said that it is. Now what we're going to do is we're going to move c over to the right hand side, subtract 27 from both sides, leaving a space where c was on the left hand side. Off to the side of our paper, we're going to compute 1/2 b squared. So in this case, b was equal to 12. So 1/2 times 12 is 6. 6 squared gives us 36. So we're going to add 36 to the left-hand side of the equation. We're going to add 36 to the right-hand side. By adding this 1/2 b squared to the left-hand side, it'll make it a binomial squared, where the first term will simply be the variable x. The second term will be the 1/2 b, what we computed as 1/2 b inside the set of parentheses here over to the side before we squared it, which in this case was a positive 6, so it factors into x plus 6 squared. And you can still check yourself. If you FOIL that, x plus 6 times x plus 6, it gives you x squared plus 12x plus 36. Simplify the right hand side, becomes 9. So now all the variables are being squared. In other words, we can continue solving the equation by extracting the roots. Take the square root of both sides, not forgetting your plus or minus. We're left with x plus 6 is equal to plus or minus 3. Solve for x is equal to negative 6 plus or minus 3, which of course are like terms, so we can combine them. Negative 6 plus 3 gives us a negative 3, and negative 6 minus 3 gives us negative 9. The same two solutions as we got by factoring, just showing you the steps for completing the square and that it does always work. But we notice it's still a pretty long method, so if we can solve by factoring or extracting the roots, we certainly want to. Example 2, x squared plus 85 is equal to 18x. It's obviously a quadratic equation. We're going to put it in standard form, noticing that it cannot be solved by extracting the roots. Not all the variables are being squared. Now that it's in standard form, we see we cannot solve by factoring either, so we're going to have to use the completing the square method. Begin by making sure a is equal to 1. It is. Now what we're going to do is move that constant over to the right hand side, subtract 85 from both sides, and then off to the side of our paper compute 1/2 b squared. Well, in this case b is equal to negative 18, so 1/2 times negative 18 is negative 9. Negative 9 squared is a positive 81. So add 81 to the left hand side of the equation, add 81 to the right hand side. That makes the left hand side factor into a binomial squared. The variable x, the constant is going to be the 1/2 b, whatever is inside the set of parentheses before you squared it, which in this case was a negative 9. So x minus 9 squared is going to be equal to negative 4. Now all the variables in the equation are being squared, so we can solve now by extracting the roots. Take the square root of both sides, not forgetting your plus or minus. The left hand side, x minus 9 is equal to the right hand side. Plus or minus the square root of negative 4 becomes 2i, an imaginary number. Solve for x is equal to 9 plus or minus 2i. Two solutions. Make sure they're in the form a plus bi, and of course they are. 9 plus 2i, 9 minus 2i. So let's go back up to that example 5, and we're going to solve this one using the completing the square method again, just for practice. We said we cannot solve by extracting the roots, we cannot solve by factoring. So it's in standard form, a is equal to 1, move that c over to the right hand side. So add 7 to both sides. Off to the other side of our paper, compute 1/2 b squared. Well, b in this case is a negative 1. So 1/2 times negative 1, negative 1/2 squared gives us a positive 1/4. So add 1/4 to both sides of the equation. The left hand side then was going to factor into x minus 1/2, the 1/2 b before we squared it. The right hand side, 7 plus 1/4, come up with a common denominator, combine like terms, 29 over 4. Continue solving by extracting the roots. Take the square root of both sides, not forgetting your plus or minus, so x minus 1/2 is equal to plus or minus the square root of 29 over the square root of 4, which of course becomes plus or minus the square root of 29 over 2. Solve for x, add 1/2 to both sides. X is equal to 1/2 plus or minus the square root of 29 over 2. Which we can combine those two fractions into one. They already have a common denominator, 1 plus or minus the square root of 29 over 2, which is simplified at this point. But there are two solutions still, so you could separate them. 1 plus the square root of 29 over 2, 1 minus the square root of 29 over 2.